Now we're going to talk about the Node.js driver and CRUD operations using MongoDB. You've already been using the Mongo shell to do CRUD operations, having them converted to BSON by the shell, and then sent to the MongoD process, which is our running instance of the MongoDB database. This section is just going to be about how to use the Node.js driver and what the CRUD interface is within the driver. Let's work with a new dataset for these examples. We'll also look at how to import data into MongoDB using another command. So here I have a file of startup company data from the TechCrunch database called Crunchbase. In case you're not already familiar with it, you can find Crunchbase at crunchbase.com. Here you can find all sorts of details about startup companies, such as what rounds of funding they've gone through so far, who are the current executives, and so on. Now this file contains a dump of more than 18,000 company records from Crunchbase. It contains one JSON object per line. To import this data into MongoDB, we can use a command called mongo import. Now, rather than working with a binary dump file, as does mongo restore, which you've already used, mongo import allows us to import human-readable JSON into a specific database and collection. To import this dataset, we'll type the following. Now, there's quite a bit of data there, so it took a second or two to import all of these documents. Now let's check this in the Mongo shell. We can use the Crunchbase database, and now we can do a quick find on the companies collection. And we see that we've got, in fact, that number of records. Just take a look, and sure enough, here's one of the documents. We'll take a look at the structure of documents in this collection in a little bit. Now let's look at an example of using this dataset. This program is an example of using find with the Node.js driver. We'll quickly review this and then extend it to cover some essential material about using the Node.js driver. Now, the first thing we have to do is make sure that we have a reference to the driver, as we do here. So we say for our Mongo client, require Mongo client. The next thing we do is connect to the database here. Now, you can look through the docs for the format of the connection string for things like a replica set or a sharded cluster. We discuss those more advanced concepts in other lessons. For now, we're just connecting to a single MongoD. Now, I know we've looked at earlier examples of connecting to MongoDB within the driver, but let's make sure we understand the components of the connection string, in particular the host, the port, and the database. I want to make sure you realize that if we want to connect to MongoDB running on a different host, say on a machine other than your local computer, we would need to change localhost to the name or IP address of that host. The port and database are values that we'll see being different as we move from one topic to another throughout this course. Just to give you an example, if we want to connect to the video database, I would need to change this portion of the connection string. Now let's do that and run. Now we see that one of my assertions failed because the number of documents returned is now 0. Let's go back to the code and see where that happened. Okay, that assertion statement is right here. I'm expecting the document's length to be greater than 0. This assertion fails because I'm trying to find documents in the company's collection. However, because I'm connected to the video database, no such collection exists. So let's change our database back to Crunchbase, save, and run this one more time. And the results we get back are as expected. And again, we'll go through the code in a little bit more detail just so we make sure we understand what's happening here. Before we do that, I'd like to look first at changing the port. Now, by default, when I start a MongoD, it binds to port 27017. We can see that with this example. You can see that the last statement the MongoD prints out when it starts up is that it's waiting for connections on port 27017. So what happens here, if I change this port number to something like 27018, save, and go back and run my application again. Now I can see that I'm getting a connection refused at localhost 27018 because there is no MongoD running at that port. Let me stop this MongoD and start it again, but this time I'm going to tell it to, instead of running on the default port, go ahead and run at 27018. And we can see that now it's waiting for connections on 27018, which is the port we've specified here in the connection string. Now let's attempt to run this, and there we have it. The application runs as expected. Now, I'll start this back up on the default port, and go back and change the connection string so that it references the default port again. Check to make sure we're running, and sure enough, we're all set. While for single node deployments of MongoDB, as we've been looking at, we'll continue to use the default port. When we discuss replica sets and sharded clusters, we'll see that we have to have MongoD processes running on several different ports on a machine as part of a cluster of processes that support and scale our read and write operations. Now let's talk a little bit more about this application. So as we've seen before, we're using the DB handle passed into the callback from making a connection to the database, doing a find query on the companies collection, and with the cursor we get back from find, we're calling the toArray method, which of course will consume the cursor and hand the callback function we specify here an array of documents on success or an error if something went wrong. Then we've got a couple of assertions here, one to make sure that there was no error, and the second one, as we've already seen, to make sure that we got more than 0 documents back. Finally, what we're doing here is using the forEach method for this array object, and in the callback for forEach, we're printing out whatever the name of our doc is each time through is whatever the category code is of the document. This is a field of documents in the collection that tells us what type of company a particular company is. And finally, concatenating on just the word company so that we get output that looks like this. For every company in our companies database that matches this query, we're printing out a message. For example, Novasys is a biotech company. So why did we get that? Well, let's take a look at what query we're passing. So what I'm doing here, and what I'll do for most of the exercises in this section, is we'll construct a query document, and we'll actually pass that object on to find, or whatever method we're using to interact with the database, as a means of separating the task of constructing the query from actually issuing the query itself. Okay, so in this case, our query says, give me all documents where the category code field is equal to the string biotech. And as I said, category code is merely a way that documents are classified within this collection. So in this forEach, each document in turn will print its name, its category code, as a verification that, in fact, we are matching only biotech companies. And so we end up with results that look like this. Now let's discuss in detail the use of cursors in the Node.js driver. We've talked about cursors before, but I want to take a little bit of a deeper dive to discuss a couple of issues that are of particular relevance when we're using a driver, as opposed to the Mongo shell. This is a slightly different version of the application we just looked at. Note that we have a call to the find method here, but don't give it a callback. Remember that find returns a cursor. And here, we're assigning the value returned from find, the cursor, to a variable. As we discussed in other lessons, chaining a call to the toArray method onto a call to find, as we did here in the initial version of this application, consumes the cursor and gives us an array of documents we can work with. With code written this way, instead of consuming everything at once and pulling it all into memory, we're streaming the data to our application. Find can create the cursor immediately because it doesn't actually make a request to the database until we try to use some of the documents it will provide. The point of the cursor is just to describe our query. In the initial version of this application, it was toArray that provided the need to actually retrieve documents from the database. When we did that toArray call, the driver said, okay, the client app is actually looking for all the documents and wants them back in an array. So I'll actually have to go execute the query. In this case, we haven't actually asked for anything yet. So it can just make the cursor object and return it. Now, cursor objects provide a forEach method. Note that this is not the forEach method on arrays because we're dealing with a cursor here as opposed to an array object. And the form of this method, that is to say what arguments it expects, are different. The cursor forEach method expects as its first argument a callback for iterating through the documents. It will call this callback one time for each document in the result set. The second argument to cursor's forEach method is what to do when the cursor is exhausted or in the case of an error. When we call the forEach method here, as with toArray, this is an indication to the driver that it needs to actually go get us some documents. Now let's just run this, and instead of running app this time, we're going to run our app explicit cursor, and we get the same set of results. The difference is that with the code written this way, we're streaming the documents into the application as we need them. As we need them here is defined by how this callback works. And all we're really doing here is printing them out one at a time. Now, to wrap up this discussion, I just want to remind you that when the cursor requests documents from MongoDB, triggered by something like the cursor method toArray or the cursor method forEach, the response from the database system isn't necessarily the entire result set. So consider a situation where you have a massive database with many, many documents, and you don't actually want to return the whole set of documents all at once. What actually happens is that when the cursor has to go off and get some documents, say because we called forEach, MongoDB will return a batch of documents up to a certain batch size. So in this example, when the cursor gets back that first batch of results, it can actually start passing documents to the callback we've handed forEach here. Once that initial batch runs out, the cursor can make another request to get the next batch, and once that batch runs out, can make another request, and so on, until it reaches the end of the result set. Now, this works very nicely with a method like forEach because we can process documents as they come in successive batches. Contrast this with toArray, where the callback doesn't get called until all documents have been retrieved from the database system and the entire array is built, which means you're not getting any advantage from the fact that the driver and database system are working together to batch results to your application. Now, batching is meant to provide some efficiency in terms of memory overhead and execution time, so take advantage of it if you can in your applications.